Hello and welcome back. This is part 3 of our Repair-A-Thon of HP 98035 real-time clock module boards for our HP 9825 calculator. In the last episode, we made a test setup that let us probe the clock boards while powered up. We even hooked up bubble LEDs and could actually see the nanoprocessor interact with the Texas Instruments LED watch chip when setting up the time, for example. That is, on a board that we had repaired in episode 1 and was working. We should now be ready to take on the remaining tough cases that were not repaired by simple component swaps. Okay, we have now a test setup, so I have to choose which board I'm going to try. Error 32 can be reset but loses time on reboot, so this one is a good candidate as the simplest one. The processor works but can't access the chip. So that's a number 4. Must be this one. Number 4, this one. Okay. Alright, it's a fairly hairy setup now. Okay, wasn't too bad a process. Nothing goes. Oh. The processor hasn't even started. So the flatliner. Okay, 0 Zipo, nothing. That is weird. So the first thing I can tell is that the clock chip is working. Look at that. And it has time lost. So it's the rest of the system that's not doing fine. Wait, what just happened? While I was panning the camera to the scope, magic smoke escaped. I actually did not see it until way later when I reviewed the footage, but I sure smelled it. It had the distinctive smell of magic smoke, and I can't tell if it's coming from the 9825 or something else. Not having seen the footage, I did not know where the smoke had come out, and I got really worried about my precious 9825, which had swallowed some of the bad smell through the fan. We already know the fault is fortunately not in there, but I could not resist to give you a peek at the insides of this magnificent machine. And that's the last thing I'd need is the 9825. Yeah. Alright, opens up like a book. There we go. And at the bottom you have what makes it thick, which is this large 16-bit processor. Let me see if I can show it. There you go. This guy is actually a hybrid with, I have to look it up, 5 or 6 chips in it. And it's a 16-bit NMOS processor, so it was way faster than anything had been done at the time in calculators. What's wrong with you? Nothing really. So I wonder if the board was drawing too much current. It has something shorted on it. So after this short diversion and strategic use of the smell-o-meter, I come to the correct conclusion that something bad must have happened to my clock boards. Okay, the smell-o-meter tells me that the smell comes from over here, which is the 9-volt power for the microprocessor. So the part that's smelly is this little circuit, which does the plus power to the processor, but the nanoprocessor is kind of weird. It needs the back voltage and the plus 5 volts before it gets the 9 volt or something like that. So that acts as a reset. I think this one is the guy that blew from 12. Why did it blow? Is my worry. Is that maybe the Zener blew? Anyhow, I'll just We'll just test the transistors and this. I don't want to put that in the circuit right now, not knowing what's the problem. So that's the transistor I pulled out of the board. That's a good PNP, what it should look like. So that's a good PNP. And this one is a short circuit, or not quite, but close to it. So it's it doesn't have any transistor mojo to it. The question is why did it die? Did it die just because it was a bad transistor? Or did it die because there's something on the board and that's demanding too much current? So I need to check that first. And here's the other transistor, that's Q2. It's an NPN this time. That's what a normal NPN would be. And that's the one in the, oh, hold on a second, it's not in. Yeah, there you go. That's the one from the board. So it's also a short. So they both blew. The one might have blown the other, but I'm thinking it's something with the board. So I look on the processor board, the clock board, 9 volt comes in and really goes straight into the processor. And I'm looking at the board here, and I know I was thinking maybe a tantalum blew or something. But the input impedance is 2.6K. There's no tantalum across it. There's just a regular mica, and it's all fine. So it's not that board that blew it. So either the transistor itself or maybe the zener on the board. And the impedance looks okay here. That cap looks okay. So on the other circuit there's not much either, and there's just a 10 volt zener here, so that should be rather easy to test. And here's our little zener. It's supposed to be 10 volts, 2 volts per division, so it should be, oh yeah, what a good zener. Ooh, look at that, 10 volts right on the dot that crosses the line. So I think it's a transistor death that caused another transistor death. Alright, we will replace the transistors. Also, I still don't understand how they could have blown without a short. Okay, I reconnected everything except the 9 volt wire. And though if it doesn't get the 9 volt, the processor is just not going to start, so it shouldn't do anything. And I'm definitely not getting 9 volts. Okay, that is not correct. So I had not disconnected the 9 volt pin and it burned the transistor again. So the board is has a short on the 9 volt, but I cannot see it. At least I replaced the transistor, so I should get 9 volt. Hopefully I'm on the right wire. Yeah, so that's the right wire, 9 volts came up. So I hate when this happens, when another board destroys your good one. Okay, I've reconnected the 9 volt, but I put the 100 ohm resistance to measure the current and to limit it. So if I have 9 volt across it, means I have a short at the other end. I have 9 volt across it, okay. So it's shorting. I guess I removed the nano processor then and see if that goes away. Alright, so we take the nano processor out. And my secret hope is that it still shorts, because if not, the microprocessor, the nano processor is bad, and that's a rare chip. That would be sad. 3, 2, 1. Yeah. No voltage drop, so the nano processor is fried. Well, so much for this board. It zapped its nano processor. Okay, so I'm going to stop on this one because I don't know if it's the microprocessor zapped the other board, or this board zapped the microprocessor will zap the other board, so might be a dangerous board. So let's go to another one. Ay, ay, ay. So we're going backwards. This one used to be yellow, now it's red. The next one, there is one that completely hangs and one that returns something and then hangs when you try to set it. So let's try this one. Okay, trying with the new board. I still left my 100 ohms in there to see if this one still has the same voltage drop. Okay, so that's 2 volts, so that's 20 milliamps. That's perfectly fine. So we can remove the resistor. Okay, so we're back to our pseudo-normal configuration, if you can call it normal. Nothing goes. 3, 2, 1, go. Okay, so okay, that's normal. The interrupts are running, and it's doing this the stable code before the interrupt and normal code afterwards. I didn't see it try the chip though. So it's not doing anything on the chip or what? Let me do reset. No, it's not trying to read the chip at all. But I think the clock chip works. Oh no, it does not. Interesting, because I got 32 kilohertz out of it. Hold on a second. I turned the HP 9825 off, and now I try the clock chip, and it works. Now something really interesting is happening. If I put the clock in set mode, that's the second setting, and I turn the thing on, it goes off and it comes back. If I turn the thing on longer, it goes off and takes even longer to reappear. Now what could cause that? So that's the 32 kilohertz from the clock. I wanted to know if the clock was running when I turned the thing on. And woohoo! Something happens. Now we'll stop the clock. Then it comes back. And then the time it takes to come back is proportional to the amount of time it has been on. I tried without a battery using a power supply, same result, so it's not the battery that charges and discharges. I mean, what could do that? Defective chip? Something charges inside the chip? Yet another case of a quartz crystal oscillator that picks up some random noise, but it should return when I turn it off. Why doesn't it do it? Or I don't know what my next step is. Change the clock chip, see if it happens again, and if not, maybe it's a quartz problem, or it's something in the board. So I made a last ditch effort here and removed the 32 kilohertz crystal. No, replaced it with a tiny watch one. It's buried down there, and see if it made a difference. Basically having no better idea, and it seems to have made a difference. There you go, it stays. And yes, it's reading the time. Is it? The reset? And it's reading the time. So when it gets that, the 100, and then the seconds that don't advance, it knows it has lost time. So see if it responds now with an error 16. It does! Alright, let's set it. I bet you will repair it. I bet you will repair it. So we should see if it tries to set it. And it sure does. There you go. Blah 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 blah. Oh, it's having trouble with that. Yes, no, yes, maybe. It's struggling a bit. What? He's trying hard. What the heck is that? Oh, okay, so we're making some progress. That's the day loop that it doesn't recover from. And of course, when I go over here, if I ask it to read the time, it hangs, not because the processor is hung, but because it's in a loop trying to set the clock and never comes back from it. So now it tried to set the clock, but it failed, so I stopped it, but now it has a time. Yeah, so the seconds are advancing. So now if I go through a reset cycle, it will try to read it. Read it, like goes through the thing, up. Oh, then it gets stuck into this weird condition. So there's a button still pressed and it should not. Okay, it's still trying to make sense of that weird behavior. So the first thing I did is look at what other pins could be at weird voltages. And the only ones that are driven are the one from this chip. So I remove this chip, change the clock, and the behavior stays the same. So we are at interface chip removed. So now the remote buttons are attached to nothing. And a new clock chip. And what I see is still strange and not normal. So it's better, stays on. But you'll notice that even though there is nothing attached on the chip, it's going through, it's trying to do settings. And then if you look at the setting button, it's sitting at a weird voltage. Look at that. It's moving all over the place, where a normal button, as the button next to it, should be at 0 volts. There is some leakage into that pin, even though it's connected to nothing but grounding resistors. So I was trying to figure out what could get this line shorted to something positive, and what, there's only a resistor to the ground. This I have removed, so there shouldn't be anything, except I went to look where R29 is. So my circuit I remove is there. I was looking for R29 and it's not there, it's at the other end. And guess what? So R29 is right over here, where all that corrosion is. So I bet that's our problem. It's doing a bridge to something else. So the board doesn't have much corrosion in general, but it seems to have it where it counts, or more exactly where it hurts, right here. Okay, and the vinegar it goes. Maybe I'll do just the end of the board, because the rest seems to be okay. Oh my, it is very bubbly. There sure was something there. Yeah, it's bubbly there too, so maybe I'll do the whole thing. So it was just bubbly over here and stopped pretty quick, and not much over here, so I don't know, maybe we were unlucky. It's just very little corrosion, but just exactly where it hurts. Okay, board is back on. The clock chip is fine, and now I turn it on. My set pin is not at the crazy voltage anymore, so we did something. Okay, so the vinegar repair did something. I don't know if it's enough to repair the thing. I have to put back the interface circuit. Okay, my interface IC is back in there right here. Let's turn it on. Yeah, it's not trying to read the clock. So let's try to set the clock, and I'll put ourselves on the digits. See if that will succeed this time. Execute. Nope. Nope, 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 nope. It's stuck. It's absolutely stuck. No. Well, that's weird. Okay, I can see it's not even trying to do the buttons at all. And then if I hook it up to the processor, there is no, it's a repetitive activity. The processor has not started to maybe a little bit of code. I don't think so. It's the same thing all the time. I don't see any of the interrupt spikes that I should get on the green trace. Should go down. Oh my, at least we are making some progress, and like the previous board, it looks like the processor just failed in front of our eyes. This is starting to be a bit discouraging. So I had enough of the other boards. I changed for my third one. The third one I have a little rework because it's a Rev A and I have a Rev D chip on it. So I cannot probe it directly, but this one hung. And so actually I wanted to compare the hang of this board with the new hang of the other board. And so the processor hangs same way, but this is different. I get the same response when it doesn't see the ROM. So maybe this one I can just swap the ROM, which is the only chip I haven't yet swapped on that one, and see if that would work. This is really messed up. This board is the only one with an early purple ceramic mask ROM. It's very pretty, but those are prone to failure. Let's see if swapping the ROM helps. Okay, last ditch effort. Oh! That changed things around. I don't think I'm seeing the interrupt. Am I hooked up on the interrupt? Yes. No, I'm not. Okay. Okay, there's hope. See that? Still no interrupts showing here. I got that before, when you get into that very repetitive cycle here. Usually it's not a good sign. Okay, so it's probably not running. It's doing a little bit better than with the other ROM, but not enough to run. Yeah, it hangs, of course. So this is not boding too well, unless I put a logic analyzer on it. Okay, we have brought in the cavalry, which means things are not going so well. So I finally pulled out the logic analyzer and I set it up to sniff on the ROM, which was actually not that difficult. Just put one of the grabbers, and off the ROM I can get the address that the processor is reading and the data it's reading, which should enable me, since I dumped the code, to follow the code. So the idea is to have it run and see where it goes and where it gets stuck. I'll go on run and I press reset and it should start that. There we go. Well, that didn't take very long. So we capture data. So the addresses, you see them counting, that's good. The data, it starts good. And then you can already see, man, in the first screen, you can already see it's getting stuck in some kind of a loop here. So let's see what it is and see if it makes any sense. And it has AF, it gets stuck there a couple of times, AF AD DC 49. And then we compare to what we should get. AF AD DC 70. Yeah, not reading stuff correctly or what? AF AD D3. Oh, it jumps. So D3, third instruction is a jump. And yes, third instruction is a jump, jumps to 5 DC. Okay, so that's doing what it should. So you can see it gets to that instruction, it adds address 03 and it jumps to 5 DC. 5 DC, yeah, so 5 DC is of course the reset code. So reset code is a whole bunch of stuff. I'll just verify that it's the right stuff. That it should read 49A9AC. 49A9AC, yeah, so it's reading the data correctly and return from subroutine. So that's, where is that? 5EA. So let's go to 5EA over here and it should jump to the 5. Oh, now that can be good. So that's 5EA. It reads B8, which is correct, which is returned from subroutine, and it goes right through it. It goes to 5EB. Okay, that's what I was fearing. The processor is doing all instructions correctly except return from subroutine. And well, there's absolutely nothing I can do about that. It's about processor. It's not about ROM. So then it goes through, it falls through the next code, which has absolutely nothing to do with what it should do. So it should return here. Instead, it does, it gets into some subroutines. Let's see if there is another jump in there somewhere. You know what? I can just figure out here where it jumps. So there does a good jump. Go from 01 to 04. 601. Skip on accumulator. It skips that. It skips over, so it's doing the right stuff here. Although it shouldn't be here at all. Here is another big jump. 611. It goes to 700. 611 is shouldn't jump at all. 611. What is it? So it reads D0, reads D0, and D0 is a store value in register. And instead of that, it jumps to 700. So okay, so I think I'm mostly hosed here. I'm still going to try to see if I can remove my my nano processor. And you see that handwritten on it, it has the back voltage. So every nano processor has a specific back voltage, and if you change one for one with a different back voltage, you have to change a resistor somewhere.
Whoa, 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 freeze! See that bent pin? Let's keep on going for now, but we'll sure need to come to it later.
But the other one is also a 5-volt one. Actually, this one is written, is from later. This is written by a machine instead of being written by hand. So I don't have to change any resistor. And hopefully this one doesn't have a short. Alright, let's try this one. Alright, here we go. Processor number 2, so I do run. I go over there, press the reset button, reset, and catches it. Oh, it's already done. Okay, this one is a lot better behaved. So it does its first 3 instructions. It jumps at 5 DC, which was the reset stuff. And at 5 EA, it actually returns to, so it instruction 4, it left at instruction 3, returns to instruction 4. And then I see it can repeatedly in a loop, but that's actually a perfectly legit loop. It's doing a RAM check. So maybe we'll let it run and I'll try, maybe it actually works. Unfortunately, I cannot probe the clock on that one. Let's see. Yeah, error 0. It works. Gee wee, we got 1. Yeah, it reads the time. We got 1 repaired out of 3. 1 repaired, 2 bad processors. 1 that's shorted and 1 that cannot return from a subroutine. Okay, so that fellow did necessitate the logic analyzer, but it had a bad clock chip, no, a bad 32 kHz crystal, a bad nano processor, and it had a bad ROM. So it had many bad things in it. So which is interesting because board 1 we repaired crystal. It had a pseudo short, so it cleared with the vinegar, and then it was still hanging up, but we just took the processor and put it here, and the processor works. So I got irritated with that one, went to that one. So it might be interesting to figure out why this one hangs if it's not the processor. So I put the processor that we just used to revive the other board back onto our vinegared board. That kind of almost worked for a while and then stopped working. And I thought it was a processor, and obviously it's not. So I'm sort of intrigued to what it could be. So we'll do a trace on it. And off we go. Oh! It's working! It's doing the interrupts. I don't know what was happening before. So the whole trace exercise might be kind of silly, because if I do error, oh, it has error 16, set the time, read the time. It's still setting the clock. I can see it on the scope when it's doing this. It means it's reading digits. So now it's able to set the digits. Yeah, it came back. We got the time. Oh, we repaired 2. Except we don't have enough processors to power them all. There you go. We have a clock that works. So I have no idea what happened. The vinegaring did the work, and it must not have been well in its socket or something like that. But it's repaired. Okay. Okay, so this one didn't have much wrong with it. It just had the crystal and the hidden short caused by corrosion that we cleared with the vinegar. So, and I'm not even sure that the crystal was that bad. It might also have been slightly shorted and wasn't strong enough. So we'll call it, this one was repaired by vinegar. So, okay, this one gets, well, it's green in theory, but we don't have a processor to run those two at the same time.
But wait a second. We have a processor that seems to be sort of working, but misinterprets some instructions. That is very suspicious. Looks like a Voodoo vintage electronic curse to me. Remember that I was not probing data at the processor, but at the ROM pins. Could it simply be that one of the processor data pins was not making good contacts with its socket?
So fellows, wouldn't you know it, I had a bad feeling about that processor that kind of almost worked but didn't return from its subroutine. So that's the one with the handwritten -5 volts. And sure enough, I looked at it, it had one pin that was slightly bent up and might not have made a consistent connection. So now it's in, and guess what? Yeah, we have interrupts, it's executing code, and you look over here. Right, we can read the time from it. And let's see if it has any errors. No, no errors. It's working perfectly fine. So, after all this, we actually have 5 solid greens. Now we have enough processors to run them all. And just one really red board because the processor is shorted, and also it donated its ROM to the one that had the bad ROM. No, remaking a ROM is not difficult, but no, finding a new processor or making an emulation thereof is just possible, but way too difficult. If you work hard enough, you'll get them repaired, but boy was that difficult, particularly on the one that had such a weird behavior because of the corrosion. Anyhow, no, you get the point. I still have yellow boards. These are the other boards, but no. This was so long and so difficult, I don't know that I have the courage to do those 3 last ones. Let me know in the doobly-doo if you want me to go after these, or if we should call it quits. I think we got the better of the Voodoo electronics here. Alright, see you in the next episode.